Hello students, in this video we will solve the previous year 2018's questions. We will try to solve the electrical part here. So, first question, the electrical energy consumed in the month of April by 5 incandescent bulbs of 100 watt each glowing for 5 hours a day in a domestic household. Here you can see that we have 5 number of bulb each having 100 watt for 5 hours a day for a month of April. So the total energy will be 5 into the 100 watt into for the 5 hours 5 into for the month of April, that is 30 days, divided by 1000 to find the kilowatt. 20 cancel, here 10 cancel, so it is 5 into 5 into 3, that is 5 into 5 25 into 3, that is 75 kilowatt hour. So option C is the correct answer. In the next question, which of the following single phase induction motor will develop relatively high starting torque? So for high starting torque, the capacitor start motor having the high starting torque. So option D will be the correct answer. In the next question, if mechanical load on the shaft of a DC series motor is suddenly increased, its speed will reduce rapidly. For a series DC motor, the speed and load characteristics, this is load current and this is speed. So the characteristics like this, that means whenever the load current increases, the speed will decreases. At no load, that means at zero current, you can see that the speed is very high. Its speed is dangerously high. That is why the series motor never starts without any load. In the next question, for a DC voltage and inductor, you know that DC voltage have frequency is 0. For inductive reactance, XL, that equal to 2 pi into F into L, where F is the frequency. For DC, by putting F equal to 0, this value will be 0. That means for a DC voltage, inductor is of short circuit. 0 resistance, XL is in ohm, 0 resistance means that is virtually short circuit. So option A will be the correct answer. In the next question, in a steam power plant, water is used for cooling purposes in both boiler tubes and turbine. That is option D will be the correct answer. In the next question, the speed of a 50 horse induction motor under full load condition is 720 rpm. The number of poles of the motor are, in the question, the speed of the motor is given as 720 rpm. We know that for a induction motor, the rotor speed is close to the synchronous speed. The synchronous speed is given by ns equal to 120 f by p, where f is the frequency and p is the number of pole. For a 2-pole, the synchronous speed will be 120 f by p. So putting p equal to 2, we will get 3000 rpm. Similarly, For 4 pole, the speed is 1500 rpm. And for 6 pole, the speed is 1000 rpm. And for 8 pole, the speed is 750 rpm. And we know that the speed of the induction motor is close to the synchronous speed, that is 750 rpm. Here we have 720 rpm, so close to 720 is 750 rpm. So our option will be 8 pole, that is option C will be the correct answer. In the next question, two incandescent light bulbs of 40 watt and 60 watt ratings are connected in series across the mains. Then you see, the lower the power, the brighter the lamp. That 50 watt bulb glows brighter. Option D will be the correct answer. In the next question, a 100 watt light bulb burns on an average of 10 hours a day for 1 week. The weekly consumption of energy will be days units. So we have 100 watt bulb for 10 hours in a day for 1 week. That is 100 into 10 hour into 7 days. That equal to 7000. So for unit we will divide 1000. So 7000 divided by 1000, that equal to 7 units. That is 7 kilowatt hour. So it is 7 unit. Option A will be the correct answer. In the next question, the incandescent bulbs rated respectively P1 and P2 for operation at a specified main voltage are connected in series across the mains as in the figure. Then find the total power supplied by the mains to the two bulbs. So for such arrangement, the total power will be P1 into P2 by P1 plus P2. Option A will be the correct answer. In the next question, ELCB is an abbreviation for it is a circuit breaker, that is earth leakage circuit breaker. Option D will be the correct answer. In the next question, inside the earth's orbit, the earthing electrode should be placed vertically. Option A will be the correct answer. In the next question, a 0 to 300 voltmeter has an error of plus or minus 2% of full scale deflection. If the true voltage is 30 volt, then the range of reading on the voltmeter would be, see here, the range is 0 to 300. So having plus or minus 2% error. That is, let us find the percentage error for full scale. 300 into 2%. So 302% is, we will calculate is, it will be of 6 volts. So for 300 voltage, it is 6 volt. So plus or minus 6 voltage is the error. That is, here the error is 6 volt. Here true voltage is 30 voltage. So it is 30 plus or minus 6 volt. That is 36 volt and 24 volt. Option B will be the correct answer. In the next question, torque weight ratio of an instrument indicates torque to weight ratio of an instrument indicates its sensitivity. Option D will be the correct answer. In the next question, a DC voltage of 250 volt applied to a resistance of R in series with an ammeter A of 0.1 ohm internal resistance, the reading of the DC ammeter A is 10 ampere. The value of the resistance R in ohm will be, as per the question, we have the circuit current as 10 ampere and internal resistance having an ammeter 0.1 ohm is connected in series with this circuit, and a supply voltage is provided as 250 volt and the circuit resistance is R ohm. Here we have to find this R value. So we know that the total resistance will be here R plus 0.1 ohm, that is series with this. So the total resistance will be RT equal to R plus 0.1, and the circuit current which is given as 10 ampere, that equal to V by RT, 250 divided by the total resistance R plus 0.1, that equal to 10. So with calculating this, we will get R equal to 24.9 ohm as the correct answer. In the next question, most of the generators of the grid connected thermal power plants in India runs at a speed of 3000 rpm. In thermal power plant and nuclear power plant, the speed is high, that is 3000 rpm. For hydroelectric power plant, the speed is low. In the next question, the type of wiring system preferred in cold storage and damp places are PVC wiring will be the correct answer. In the next question, high pressure mercury vapor lamps are used for the high pressure mercury vapor lamps are generally purpose use, that is for the street lighting. Option A will be the correct answer. In the next question, function of a choke in the fluorescent tube is used in a household wiring is to reduce the starting current. Option B will be the correct answer. In the next question, the size of earth or ground wire depends on both A and C, that is for the maximum fault current passing through the ground wire and depends on the soil resistance. In the next question, the charge of a lead acid battery can be restored by adding acid to the electrolyte. Option C will be the correct answer. In the next question, the location of the source tank in a hydroelectric power plant is very close to the turbine gate. Option C will be the correct answer. In the next question, electrolyte used in lead acid battery is the electrolyte which is used in lead acid battery is sulfuric acid. Option A will be the correct answer. In the next question, the current which can be approximately drawn for 10 hours from the battery of 3 ampere hour of 2 volt is. Here you can see that the battery rated as 3 ampere hour, that is 3 for the 10 hour, it will be of 3 by 10, that equal to 0.3 ampere is the correct answer. Next question, two wires A and B of the same material and length L and 2L have radius R and 2R respectively. The ratio of the specific resistance will be, we know that the specific resistance is depends on the material. It does not depend on the size of the conductor. So the correct answer will be 1:1. In the next question, in the figure given below, the value of R is, here we have to find the value of R. As for the question, we have the circuit diagram like this. 10 ohm and 10 ohm are connected in parallel, and R ohm is connected in series with this parallel combination, and the circuit current is 8 ampere and the circuit voltage is 100 volt. So the circuit current I equal to B by R equivalent, that equal to 100 is the voltage divided by R equivalent will be 10 ohm parallel with 10 ohm in series with this R ohm, that equal to, with calculating this, we will get 7.5 ohm is the correct answer. So R equal to 7.5 ohm. So the correct answer is option C. In the next question, the elements which are not capable of delivering energy by its own are known as passive elements, and those elements which are capable of delivering energy are called active energy. So here it is not capable, that is option D. Passive element is not capable of delivering energy. In the next question, a practical voltage source is represented by option A. That is, a practical voltage is represented by a resistance in series with an ideal voltage source. Here I am giving you one more important point, that is, for ideal voltage source the internal resistance is 0, and for ideal current source the internal resistance is infinity. In the next question, the RMS value of the voltage ut equal to 3 plus 4 cos 3t is, here you can see that this 3 is the DC voltage, 4 cos 3t is the AC voltage. So the RMS value will be 3 square plus 4 square divided by 2 and its root over, that equal to 3 square is 9 plus 4 is 16, 4 square is 16 by 2, that equal to 8. So 9 plus 8 and its root over, that equal to root over of 17. So option A will be the correct answer. In the next question, an induction coil is switched on to the AC mains supplying a power at 230 voltage 50 Hz. The frequency of the instantaneous power associated with it, the instantaneous power is 2 omega, that equal to frequency is the double of the frequency, that is here it is 50 Hz, that means the instantaneous power of frequency will be 100 Hz. Option C will be the correct answer. In the next question, a circuit component that opposes the change in circuit voltage is, the change in circuit voltages which opposes is the element is called capacitance. Capacitance opposes the change in circuit voltage, and inductance opposes the change in current. In the next question, a circuit of zero lagging power factor behaves as a purely inductive circuit. Option A will be the correct answer. For zero leading, the circuit will be a capacitive circuit. In the next question, power factor of an ordinary electric bulb is slightly less than unity. Option D will be the correct answer. For pure resistance, the power factor will be unity. For inductive circuit and coil, the power factor is lagging, and for the capacitive, the power factor is leading. In the next question, in a two-element series circuit, the applied voltage and resultant current are respectively Vt equal to 50 plus 50 sin 5 into 10 to the power 5t voltage, and It equal to 11.2 sin 5 into 10 to the power 5 plus 63.4 ampere. nature of the elements will be, here you can see that both these functions are having sinusoidal function and having omega equal to same, that is 5 into 10 to the power 5. Here you can see that extra angle is there, that means only the capacitive circuit will be given as plus theta angle. So that means this circuit will be of RC circuit. You can see that here this is two elements, otherwise you can say that it is a RLC circuit. Here it is two element, that means this is a RC circuit. In the next question, the direction of the rotation of the three-phase induction motor can be changed by changing the supply phase sequence. You know that the phase sequence is given by R, Y, P. So by changing this supply phase sequence, the rotation of the three-phase induction motor can be changed. In the next question, the frequency of the EMF induced in the rotor circuit of a three-phase 50 Hz 4-pole induction motor running at 1425 RPM is, you know that the synchronous speed ns equal to 120 F by P. For a 50 Hz and 4-pole it will be of 1500 RPM. So the slip S equal to ns minus n by ns. So that equal to 1500 minus 1425 by 1500. So that equal to 75 divided by 1500, that equal to 0.05. The rotor frequency F dash equal to slip into F. Here you can see that the slip is 0.05 into the frequency is 50, that equal to 2.5 Hz. Option C will be the correct answer. In the next question, the mechanical force developed in a straight conductor of length 25 cm carrying a current of 80 ampere and lying at right angles to a magnitude of field of 0.5 T will be. So the mechanical force F equal to given by B into I into L into sin theta. So here B is 0.5 into current is 80 ampere into length is 25. So 25 by 100, that will give us the in meter into sin 90. Sin 90 is 1. So this will give us 100 Newton. Option C will be the correct answer.